All right, so we are still in section 4.2. It's a pretty long section, but of course, with every new type of function we learn, we need to learn about what kind of things can be plugged into that function. So what are the domain and range of those functions? So today we're just going to focus on the domain since we have 6 trig functions to worry about. All right, so we're going to talk about the domain of each one of our trig functions. Okay, so let's start with sine and cosine. We're going to talk about those together. And I think I should split this into like 2/3 and 1/3 so we have all the space. And so on this side, we're going to talk about the function. And on this side, we're going to talk about the domain of that function. Okay, so let's start with sine of t. So t is our angle, and t can be any number that we want. Okay, so that's perfectly fine. T can be whatever we want, and we discovered that sine of t is just going to be the y value for our point. Okay. All right, so again, this is like when we're using the unit circle and we're talking about points along the unit circle, sine of t is just y. Also, cosine of t is x. All right, so we actually have 0 issues with plugging in any t value. We're going to get whatever the x value is and whatever the y value is, so we don't have any issues with this. If you try to take sine of something or cosine of something on your calculator, you can choose whatever numbers you want and you will get an answer. So the domain for sine and cosine are all real numbers, so from negative infinity to positive infinity. So this should be the easy one to remember. Okay, now let's talk about tangent. It's a little different. So tangent of t, as we know, is y over x. What do we notice here? We have a fraction. So that means there could be some issues here if the denominator of this fraction is 0. So we want to make sure that x is not 0. But question, when we're working on a unit circle, what is x? X is actually cosine. So this means that cosine of t cannot be 0. All right, so a little side note, remember, tangent of t is sine of t divided by cosine of t. So that means cosine of t cannot equal 0. So now we have to think about, okay, what kind of values will make cosine of t 0? Luckily, we have a unit circle to help us out. All right, so remember, cosine is our x value. So let's look on our unit circle. Where do we have x value equals 0? Well, we have it right here at pi over 2. Cosine of pi over 2 is 0. So that means the angle that we're working with cannot equal pi over 2. If so, cosine of pi over 2 is 0, and we can't divide by 0. So pi over 2 is not in the domain of tangent. Okay, let's keep going. We're looking for x values equal to 0. That also happens at 3 pi over 2. All right, and we can keep going, right? We go around and we'll go around again, remember, adding another 2 pi. So this is the location of pi over 2, but if we go around again, it's also the location of 5 pi over 2. So t can also not equal 5 pi over 2. We could have gone in the reverse order, negative pi over 2. And so on. All right, so we're actually going to get an infinite number of angles that t cannot be. So we need to come up with a way to write this in a shorter way than just writing a bunch of numbers down. All right, so to recap, tangent is sine over cosine. We want to make sure that we don't divide by 0, so we need to make sure that the denominator of tangent is not equal to 0. So we have to make sure that cosine of t does not equal 0. And so we found on our unit circle that the different values for t that would make cosine equal to 0 are pi over 2, 3 pi over 2, 5 pi over 2, and negative pi over 2. And there are also many more. So we can write that the domain of tangent of t is all real numbers except odd multiples of pi over 2. And so that classifies everything we have here. Odd multiples, so 1, 3, 5, negative 1, all odd multiples of pi over 2. All right, let's look at another one. Let's go to cosecant. Cosecant of t is the reciprocal of sine, so 1 over y. We got another fraction here, so we want to make sure that y does not equal 0. We also want to remember that cosecant of t is equal to 1 over sine of t. So that means in order for us to not divide by 0, we need to make sure that sine of t does not equal 0. So we need to find all values of t, so all angles that make sine of t not equal to 0. So let's find all of those values for t that make sine equal to 0. So remember, sine is our y value. So here's the first one right here at the angle 0. All right, sine of 0 is 0, so we don't want to include 0. Where else do we have y values of 0? We go around right here at pi. So that means our angle cannot equal pi. And we can keep going around 2 pi, negative 2 pi. So let's see, we went around, got to 2 pi, we can go again, that would be 3 pi, or negative 3 pi. So basically, if you plug all of these numbers and many more into sine, you'll get 0. So that means the domain of cosecant of t is everything except multiples of pi. All right, so we're going to say all real numbers except multiples of pi. Okay. All right, let's move on to the next one. We only have a couple more. Let's talk about secant. Secant of t, that's 1 over x. That means x cannot equal 0. Well, we remember that secant is actually 1 over cosine. So in order for secant of t to be defined, we need to find all the places where cosine of t does not equal 0. And we found this before, right? We found it up here when we were working with tangent. All right, so that means t can't equal pi over 2, or 3 pi over 2, or 5 pi over 2, etc. All the things we found above. So that means secant has the same domain as tangent, which makes sense because they have the same denominator. All right, so the domain of secant t is all real numbers except odd multiples of pi over 2. All right, so can we kind of see what's happening? Could we figure out the domain of cotangent? I think you can. We'll do it together, of course. All right, so last one, cotangent of t. All right, remember cotangent is the reciprocal of tangent, so it will be x over y. We got a fraction. We want to make sure the denominator does not equal 0. All right, so again, we know that cotangent is the same thing as cosine of t divided by sine of t. We have sine in the denominator. So that means we don't want sine of t to be 0. Well, that should look familiar. We did the same thing with cosecant. It's going to have the same domain. We cannot include all of the places that make sine of t be 0. So places like 0, pi, 2 pi, negative 2 pi, etc. So the domain of cotangent of t is going to be the exact same as the domain of cosecant. So it's all real numbers except multiples of pi.